Welcome to the Network Plus Prepcast, your dedicated audio companion for mastering every objective on the CompTIA Network Plus certification exam. This series is produced by baremetalcyber.com. In every well-managed network environment, two foundational capabilities stand out: network discovery and performance monitoring. Whether you're responding to an incident or planning infrastructure upgrades, these tools give you the visibility you need to understand how systems are connected and how well they are functioning. Without discovery, you're operating blind, unable to know which devices are active, where they are located, or how traffic is flowing. Without monitoring, you won't see problems developing until users start to complain. These capabilities are not just useful, they are essential for both proactive and reactive troubleshooting, and they form the core of many questions on the Network Plus exam. In this episode, we'll explore the protocols, tools, and techniques used to identify devices, map network topologies, and track performance metrics in real time. We'll cover active and passive discovery, flow monitoring, alerting thresholds, and the role of dashboards and centralized network visibility. You'll learn how SNMP, NetFlow, and discovery protocols work together to show you what's connected, how much traffic is flowing, and where problems are beginning to develop. These skills are used daily by IT professionals and are vital in certification scenarios that require interpreting network behavior or evaluating monitoring tool output. Network discovery refers to the process of identifying and cataloging the devices and interconnections within a network. It can be used to find routers, switches, endpoints, servers, and wireless access points, as well as to determine how they are connected to one another. Discovery tools use a combination of active and passive techniques to learn which devices exist, what interfaces they use, and what protocols they speak. The result is a logical or physical map that helps technicians visualize the network structure, document device roles, and track changes over time. Two of the most commonly used discovery protocols are CDP, Cisco Discovery Protocol, and LLDP, Linked Layered Discovery Protocol. CDP is Cisco proprietary and is typically used in all Cisco environments. It allows devices to announce themselves to directly connected neighbors and share information such as host name, interface name, IP address, and platform type. LLDP, on the other hand, is vendor numeral and works across devices from different manufacturers. Both protocols help identify which devices are connected to which switch ports, an essential step in mapping cabling and verifying configurations. Active and passive discovery methods each have their strengths. Active discovery involves sending probes or requests to other devices, such as through ICPP, tracer route, SNMP polling, or port scans. It's fast and thorough, but it generates traffic and may miss devices that block probes. Passive discovery, in contrast, listens to existing traffic or logs to infer device behavior and presence. It doesn't generate traffic, but it may take longer to build a complete picture. The most effective approach combines both, using active scans to get immediate results and passive monitoring to catch devices that only show up intermittently. Mapping your network topology is the practical outcome of network discovery. With the data collected, you can diagram the physical and logical connections between devices, often layered into access, distribution, and core tiers. These maps help you visualize how traffic moves, where redundancy exists, and which areas may be oversubscribed. They also make onboarding new technicians easier and are invaluable during troubleshooting, especially in large or dynamic environments. Updating documentation after a discovery scan ensures that your network maps reflect current reality rather than outdated assumptions. SNMP, or Simple Network Management Protocol, plays a central role in ongoing performance monitoring. SNMP polling allows management systems to request data from network devices at regular intervals. These queries return metrics such as CPU load, memory usage, interface traffic, error counts, and temperature readings. SNMP traps are unsolicited alerts sent by devices when certain thresholds are exceeded, such as link down events or high interface utilization. SNMP-based systems provide the raw data used to build dashboards, generate alerts, and detect trends. NetFlow and SFlow are flow monitoring technologies that complement SNMP by focusing on traffic movement rather than device status. NetFlow, originally developed by Cisco, records information about flows essentially summaries of conversations between source and destination addresses over time. SFlow, an industry standard, provides similar data but includes occasional packet samples. These tools show you who is talking to whom, how much data is moving, and what protocols are in use. They don't capture full payloads, but they provide invaluable visibility into traffic patterns and application behavior. Threshold-based alerts allow you to take action before a user reports a problem. You can define thresholds for bandwidth usage, packet error rates, CPU or memory utilization, and even temperature. When a value exceeds the set threshold, the system generates an alert through email, SMS, or dashboard notification, allowing administrators to investigate immediately. Properly tuned thresholds strike a balance between noise and early detection. If your alerts are too sensitive, they'll be ignored. If they're too lax, they'll miss critical incidents. Effective thresholding is a key element of automated network monitoring. Dashboards and full-featured network management systems, NMS, provide a unified interface for viewing discovery and monitoring data. These platforms aggregate metrics, display trends, and offer drill-down visibility into device health. Popular tools include SolarWinds, PRTG Network Monitor, and What's Up Gold. They visualize uptime, interface status, bandwidth graphs, and inventory management. Some also integrate configuration backups, syslog analysis, and inventory management. Dashboards give technicians and managers alike a quick overview of network performance, and they become central to troubleshooting and capacity planning. Key metrics to monitor include bandwidth utilization, how much of the available throughput is being used, and interface error or discard rates, which point to quality issues or faulty cables. Uptime monitors confirm whether a device is reachable, while response time tracking shows how long it takes for devices to respond to requests. Monitoring these values over time helps detect patterns that point to degradation or misconfiguration. A single spike may be normal, a consistent upward trend may signal a deeper problem. Knowing which metrics matter and how to interpret them is essential for managing a healthy network. For more cyber content and books, please check out cyberauthor.me. Also, there are other podcasts on cybersecurity and more at baremetalcyber.com. One of the most valuable techniques in long-term network performance tracking is establishing a baseline. A performance baseline defines what normal looks like for your environment. By recording typical bandwidth usage, response times, error rates, and other key metrics during periods of healthy operation, you create a reference point against which future measurements can be compared. This helps identify when performance begins to degrade gradually, even before it reaches the point where users complain. Baselines are particularly useful after network changes, such as new device deployments or configuration updates. If performance drops after a change, you'll know exactly what's different. Detecting bottlenecks and congestion is a key use case for performance monitoring. By observing interface utilization, queuing statistics, and retransmission rates, you can pinpoint where traffic is backing up. High CPU usage on switches and routers may indicate overtaxed hardware or misrouted traffic. Dropped packets and retransmissions suggest congestion at layer 2 or 3. Monitoring these values helps differentiate between a saturated link and a hardware fault. It also supports proactive planning, identifying the need for link upgrades or redistribution before they become urgent. Logs play a critical role when integrated with monitoring tools. Syslog entries and Windows Event Viewer logs capture events such as link flaps, configuration changes, authentication failures, and more. When logs are ingested into monitoring platforms, they can be correlated with performance spikes or outages. For example, if CPU usage spikes on a router and a log entry shows a new ACL was applied, the two can be linked. This correlation provides powerful insight into not only what happened, but why it happened. Integration between logs and metrics helps complete the diagnostic picture. Wireless networks also benefit from monitoring, though they present additional variables. Performance monitoring for wireless includes tracking signal-to-noise ratio, SNR, retry rates, and access point AP load. Monitoring which clients are connected to which APs helps identify whether one access point is overloaded or if clients are clinging to distant APs when better ones are available. Roaming patterns and client reassociation events can indicate if wireless handoff is smooth or problematic. Noise and interference levels reveal when environmental factors are reducing wireless performance, even if the wired infrastructure is healthy. For technicians comfortable with the command line interface, CLI, several built-in discovery and diagnostic commands provide instant insight. On Cisco devices, Show CDP Neighbors displays directly connected devices and their details. The Show Interfaces command reveals link status, error counts, and utilization. Show version provides hardware and software details that are helpful for inventory or compatibility checks. These commands can be used independently or to supplement what you see in centralized dashboards. Even in cloud-connected or controller-based environments, the CLI remains a reliable, low-latency source of truth. Cloud-based monitoring solutions expand visibility into hybrid and remote environments. Tools like Datadog, Logic Monitor, and Ovic allow organizations to monitor networks from anywhere, integrating on-prem and cloud resources into a single view. These platforms support alerting via email, SMS, mobile app, or webhook. Some even support APIs for custom integration with help desk systems or automated response frameworks. Cloud-based monitoring tools are especially valuable for distributed teams and multi-site organizations that need centralized visibility without deploying local infrastructure in every location. For the Network Plus exam, expect questions that test your understanding of discovery and monitoring tools. You may be shown output from a discovery protocol and asked to interpret what it reveals about a connected device. You might need to match SNMP, NetFlow, or syslog to their correct use cases. Scenario-based questions may describe symptoms, such as slow performance or rising error rates, and ask which metric or tool would help isolate the problem. Recognizing the purpose and function of each monitoring method will help you select the correct approach in both exam questions and real-world situations. To summarize, network discovery and performance monitoring are core components of reliable network management. They allow you to detect problems early, visualize system relationships, and optimize resources. Discovery protocols help map connections and maintain accurate documentation. Monitoring tools track trends, detect anomalies, and alert you to thresholds being exceeded. Whether you're building a new environment, supporting daily operations, or troubleshooting a complex issue, visibility into your network is everything. Without it, you're guessing. With it, you're in control. When you combine active discovery, passive monitoring, alert integration, and historical baselining, you get a complete picture of the network's health, and with that knowledge, you can respond faster, plan smarter, and reduce downtime across the board. These techniques don't just support troubleshooting, they enable excellence in ongoing network management. Thank you for listening to this episode of the Network Plus Prepcast, your trusted audio guide to the CompTIA Network Plus certification. This episode was produced by baremetalcyber.com. For more cybersecurity podcasts, books, and resources, visit baremetalcyber.com. Thanks for joining us for this episode of the Bare Metal Cybersecurity Plus podcast. For more episodes, tools, and study support, visit us at baremetalcyber.com. And before you take the test, make sure to check out the practice questions in the book Achieve CompTIA Security Plus SY0-701 Exam Success by Dr. Jason Edwards. They cover every domain and are a powerful way to lock in your knowledge.